One incorrect assumption can undermine an entire difference in differences study. You can have clean data, professional graphs, and a statistically significant coefficient and still reach the wrong conclusion if your comparison group does not represent what would have happened without the intervention. In this video, I'll explain what difference in differences is really estimating, why a simple before and after comparison is often misleading, and the questions an applied researcher should ask before trusting the results. By the end, you should be able to look at a proposed difference in differences study and ask the most important question: do I believe the counterfactual? Now let's look at an example. Imagine a university introduces a graduate writing support program. Students who participate have an average writing score of 70 before the program and 80 right after. That's a 10-point improvement. It would be tempting to conclude that the program caused the full 10-point increase. But suppose similar graduate students who did not participate improved from 72 to 78 during that same period. They improved by 6 points without receiving the program. The difference in differences estimate is therefore 10 minus 6, which is equal to 4 points. The program group improved by 4 points more than the comparison group. That 4-point difference, not the original 10-point increase, is the basic difference in differences estimate. Difference in differences is a quasi-experimental research design. It's used when random assignment is unavailable. It combines two comparisons. First, a comparison over time, before versus after. Second, a comparison between across the groups, the treated versus untreated. The method typically estimates the average treatment effect on the treated, often abbreviated as ATT. In plain language, that means we're estimating the average effect of the intervention only among those who actually received it. The critical challenge is that we never observe the treated group's outcome after treatment in a world where they never received that treatment. That unobserved outcome, that's our counterfactual. Difference in differences uses the change in the comparison group to estimate the missing counterfactual path. Why before and after simply isn't enough? Before and after analysis cannot separate the intervention from everything else that changed over time. Graduate students may have improved because they received feedback, they may have gained experience, revised their work, or adapted to faculty expectations. Also, a university-wide writing initiative may have also happened around that same time, or specifically that semester. If those factors affect both the treatment and comparison groups, the comparison group helps account for that shared change, right? But that only works when the comparison group is credible. A comparison group is not useful simply because it did not receive the intervention. It needs to provide a believable estimate of how the treated group would have changed without the intervention. Now, the parallel trends assumption. This is the most important assumption in difference in differences, and it's the parallel trends assumption. This assumption says that if the intervention had never occurred, the treated and comparison group would have followed similar average outcome trajectories over time. The groups don't have to start at the same level, though. One department may consistently have higher writing scores than another, right? The difference alone does not invalidate the design. The important issue is how the groups were changing over time. But researchers should not reduce parallel trends to simply a visual rule that lines must look perfectly parallel, because, as you know, real world data is going to be very noisy. The more useful question is, does the comparison group provide a believable estimate of the untreated trajectory for the treated group? Suppose the treatment and comparison group generally move together before the intervention. That supports the credibility of the comparison group. Now, suppose the treated group was already improving faster before the program even began. The groups were diverging before treatment. A post-treatment difference might simply continue the earlier pattern. On top of that, convergent trends can also be concerning. Even though the groups are moving closer together, they're still following different pre-treatment trajectories. Whether groups are steadily moving apart or steadily moving together, the concern is the same. They may have been governed by different underlying trends before treatment. Now, the key question is, can parallel trends be proven? No single statistical test, unfortunately, can prove that parallel trends holds. The assumption concerns what would have happened after treatment is an untreated version of the treated group. That outcome is never observed. Researchers can, they can examine evidence that supports or weakens the assumption, but they cannot directly verify the counterfactual. Visual inspection is one source of evidence. Regression-based pre-trend tests, event study estimates, and placebo analyses can provide additional information. However, a non-significant p-value cannot prove that the trends are parallel. The test may simply lack enough data or statistical power to detect a meaningful difference. This is why researchers should describe parallel trends as plausible, supported, questionable, or unsupported, not necessarily proven or not proven. Here's the recurring question: what would a researcher do? Before fitting the model, an applied researcher would ask, were the treated and comparison groups selected for reasons connected to future outcomes? Were the groups moving similarly before treatment? Did another policy or event occur at the same time? Could participants have changed their behavior before the official start date? Could the treatment have affected the comparison groups through spillover? Did the com- did the composition of either group change over time? And most importantly, would I be comfortable defending this comparison group before a dissertation committee, journal reviewer, or policy audience? The regression comes after these design questions. A sophisticated estimate cannot reduce the or rescue an implausible comparison group. The simple graduate writing example was two groups and two time periods. This is the classic two by two difference in differences design. Many real studies are more complicated. Different schools, states, hospitals, or organizations may adopt a policy at different times. The effect may also vary across groups or change with the length of the exposure. In those settings, traditional two-way fixed effect regressions may make undesirable comparisons, including using already treated groups as controls for newly treated groups. That does not mean difference in differences is unusable. It means researchers need to use modern estimators, designs for staggering treatment timing and heterogeneous effects. And we'll cover that in a later series. For now, remember this distinction. Difference in differences is the research design. Two-way fixed effects is only one possible estimation approach. Now, before we finish, here are 5 common mistakes. First, assuming that the equal baseline levels are required. They are not. Second, treating a non-significant pre-trend test as proof. That is, it's not. Third, selecting a comparison group only because it was untreated. Untreated does not automatically mean comparable. Fourth, ignoring anticipation, spillover, or other simultaneous events. And fifth, assuming that a significant interaction coefficient establishes causality. The causal claim depends on the credibility, or more specifically, the inference of a causal claim depends on the credibility of the design, not only the p-value. Difference in differences asks a simple question. Did the treated group change more than a credible comparison group change over that same period? But answering that question, well, it kind of requires more than just running a regression. You need a believable counterfactual, a defensible comparison group, and transparent assumptions. In the next video, we'll focus entirely on parallel trends, including parallel, diverging, and converging pretreatment trends, and what each one means for an applied researcher. If you work with observational data and need to choose, defend, and communicate statistical methods, subscribe for the rest of the applied research series. Thank you.